Welcome to this comprehensive guide on creating custom event systems in Unity. We'll explore how these systems enable different parts of your game to communicate efficiently without direct dependencies, fostering a more modular and scalable architecture. This approach is fundamental for developing complex and maintainable game projects. Custom event systems are crucial for building modular and maintainable game code. They significantly reduce dependencies between individual scripts, making your project inherently more flexible, easier to extend with new features, and simpler to debug. This decoupling is a cornerstone of robust software design and game development. This centralized communication approach simplifies managing game events, ensuring that various objects are easily notified when something significant happens within your game world. It acts as a central hub, broadcasting information to all interested parties without them needing to know about each other directly, thus streamlining complex interactions. Before diving into custom systems, let's briefly understand Unity's built-in event system, found under the Unity Engine.Event Systems namespace. Its primary roles include efficiently managing selected game objects, handling various input modules, and performing raycasting operations for UI and interaction. This foundational system provides a robust framework for many common UI interactions. Unity also provides Unity Event, a powerful tool allowing you to configure callbacks directly within the inspector. This feature is incredibly useful for designer-friendly interactions, enabling non-programmers to hook up events and responses without writing a single line of code, greatly accelerating prototyping and iteration. While Unity Event offers excellent editor integration and serialization, standard C# events generally provide superior performance and lower memory usage, especially in performance-critical scenarios where every millisecond and byte counts. This makes them a preferred choice for internal engine-level communications or high-frequency events. The trade-off lies in convenience versus raw performance. Unity Event excels for quick setup and visual configuration directly in the editor, making it ideal for UI elements or simple game logic. In contrast, C# events are preferred for robust, high-frequency internal communications where performance optimization is paramount, such as in core gameplay loops or physics interactions. Now, let's build our own custom event system using the observer pattern. This fundamental design pattern involves a subject, which in our case will be our event manager, maintaining a list of observers or listeners and notifying them of any state changes or events that occur. This pattern ensures loose coupling between components. We'll start by creating a simple game event class or struct. This class will serve as a lightweight container for any data associated with the event, allowing us to pass relevant information, such as an integer score or a string message, to our listeners when the event is triggered. This ensures context is maintained. Next, we'll implement an event manager class, often designed as a singleton for easy global access from anywhere in your game. This manager will hold a dictionary or a similar collection to store lists of listeners, categorized by each distinct event type, ensuring efficient lookup and dispatch. The event manager will include register and unregister methods to dynamically add and remove listeners. These methods are absolutely crucial for managing subscriptions throughout the game's lifecycle, preventing memory leaks and ensuring that only active objects receive event notifications. Proper management here is key to a stable system. Finally, a raise or dispatch method will be implemented to trigger an event. When called, this method efficiently iterates through all registered listeners for that specific event type and notifies them, invoking their respective callback functions with any associated event data. This is the core mechanism for broadcasting events. Let's dive into Visual Studio to write the C# code for our game event and event manager classes. We'll define event types using system action delegates for simplicity and flexibility, allowing us to easily pass parameters with our events. This will form the backbone of our custom event system. We'll demonstrate how to register listeners using the += operator and unregister them with the - operator. This is the standard C# delegate subscription syntax, providing a clear and concise way to manage event subscriptions and unsubscriptions within your code. Understanding this syntax is fundamental. It's vital to unsubscribe from events and on-disable or on-destroy to prevent memory leaks. Failing to do so can lead to unexpected behavior, such as null reference exceptions when a destroyed object tries to respond to an event, and significant performance issues over time due to lingering references. This is a critical best practice. Now, let's implement our custom event system within Unity. We'll create a simple scenario to illustrate its functionality, a UI button that, when clicked, will trigger an event to change the color of a 3D cube in our scene. This will provide a clear, visual demonstration of the system in action. First, we'll create a script for our button that raises a specific event when it's clicked. This script will interact directly with our event manager to dispatch the event, passing any necessary data, such as the desired new color, to the system. This establishes the event's origin. Next, we'll create a script for the cube that listens for this color change event. When the event is received, the cube's material color will be updated accordingly, demonstrating how different game objects can react to the same event without direct knowledge of each other. This showcases the decoupling benefit. We'll also demonstrate how to pass data, such as the new color, through the event. This allows listeners to react dynamically based on the event's context, making the event system much more versatile and powerful for conveying specific information. This is crucial for complex interactions. Let's see it in action. When the button is pressed, the cube instantly changes color, demonstrating the effective and decoupled communication facilitated by our custom event system. This real-time interaction confirms the successful implementation and functionality of our event architecture. For more advanced scenarios, you can use custom Unity event types to pass parameters directly through the inspector. This combines the flexibility and designer-friendliness of Unity event with the ability to convey custom data, offering a powerful hybrid solution for specific use cases. Another powerful technique involves using scriptable objects to create more complex and persistent event systems. This allows for event definitions that exist independently of scenes, making them reusable across multiple scenes and providing a centralized, data-driven approach to event management. This enhances project scalability. When designing your event system, adhere to best practices for naming events and organizing event-related code. Clear, descriptive naming conventions, such as on-player-died or on-item collected, significantly improve readability, maintainability, and collaboration within a development team. A well-organized structure is key. Be aware of potential problems like event storms, where too many events are triggered in rapid succession, or circular dependencies that events can inadvertently introduce. Following coding guidelines, careful design, and thorough testing can effectively mitigate these complex issues, ensuring system stability. Consider when to use events versus direct method calls or other communication patterns. Events are best suited for decoupled, one-to-many communication where multiple listeners might react to a single occurrence. In contrast, direct calls are more appropriate for tightly coupled, one-to-one interactions where a specific action is expected from a known target. In summary, custom event systems in Unity offer significant benefits, including improved modularity, enhanced flexibility, and centralized communication, making your game development process more robust, scalable, and easier to manage. These advantages contribute to a more efficient and maintainable codebase. We encourage you to experiment with different event system designs and integrate them into your Unity projects. Practice is key to mastering these powerful patterns and understanding their nuances, allowing you to build more dynamic and responsive game worlds. Don't hesitate to try variations and see what works best for your specific needs. For further learning, explore Unity's official documentation on events and delegates, and delve into advanced design patterns like the command pattern or mediator pattern. The possibilities for creating dynamic and interactive game logic using these principles are truly endless, opening up new avenues for game development.